In this example, we have that a survey of 1,000 American adults conducted in January 2013 stated that 44% of them said it's too hard to adopt a child in the U.S., and that the margin of error was plus or minus 3 percentage points for a 95% level of confidence. So our relevant sample statistic here is our sample proportion. We're looking at categorical data, just yes or no. Do you think it's too hard to adopt? So our sample value is the 44%. So we'd write that as p hat equal 0.44. Then our population parameter that goes with that would be P. P stands for population parameter, and that would be looking at the proportion of all Americans who say it's too hard to adopt, where we had a sample taken of just 1,000 of them. And then we're using the margin of error to give us a confidence interval and asked if a couple values are plausible. So a way to get a confidence interval if you already have the margin of error is to take your sample value or your point estimate and add and subtract that margin of error. So if you take the 0.44 statistic of p hat and you add and subtract the 3%, which would be written as 0.03, we get an interval from 0.41 to 0.47. Those are the values that we are thinking of as plausible values. So we expect between 41 and 47% of Americans to say it's too hard to adopt. 42% is a plausible value, a 0.42, because it is in the confidence interval, but we would not expect to have a 0.5 or 50%. This sample was initially 1,000. What if we had only had a sample of 100 instead? We saw in our sampling distributions that when we took a smaller sample, we had more variability in our sample statistics. So if we have less of a sample size, we're going to expect an increase in our error. We'll have less information from our sample, and so that will come with more error in this case.